Right, hi, yeah, and this is just a really quick look at how polarised lenses work. And I'm quite lucky that the projectors, for some reason, at my university, like to polarise light. So, if you don't know what polarisation is, basically what it is when light waves travel together. As we know, white light is made up of the 7 different colours of the spectrum. Now, different types of light vibrate as they travel, and transverse waves is a 90 degree to the actual movement, but it's not as simple as that. It's not just a straight up and down movement. They tend to vibrate, or they tilt off axis. So what polarisation actually does is it actually takes the light and only lets a certain amount or a certain direction of those waves through, so either the vertical or the horizontal. So what we can see here is, if we first take a look at our blue, is that with my sunglasses, my sunglasses have polarised lenses in them. So we can see that the blue waves are travelling through here, but if I tilt my glasses through 90 degrees, we can see that the light waves no longer travel through. So we can deduce from that the fact, taking into effect, or presuming that the polarisation of my sunglasses would be vertical, then we would say that the blue waves are vertical as well, because when we turn the polarisation so now they're like that, they will only let side-on waves through, no waves actually come through, so it's darkened. So as we turn them back to the vertical again, then they're blue. So what happens when we go to the red? Well, red is exactly the same. In this case, it's exactly the same. So if I turn them vertically, again we have no colour. But if I turn them to the sideways on, so the vertical waves coming through, then we get our red light. So what happens with green? Well, green is the other way around. Now this time we've got it vertical. We're still, my glasses are horizontal, so therefore presuming that our polarisation is vertical, so therefore when I turn it through 90 degrees, our green comes through again. So therefore, it actually means that our green waves must be side on, taking this example. So what it's doing is taking those vibrations and it's making sure that only those ones can go through. So if there's only green light, then we've got no green light through. So what do we expect white to be? So we know white is made up of several colours. So if I put my glasses on horizontal, we'd expect there to be green light. And if I put them in vertical like that, then we'd expect there to be red light. Well, actually, it's the other way around, because I'm stupid. So we turn around, so as we go, we've got them horizontal, so therefore our green waves are floating across like this, and we go across to our white, and that's exactly the same case as well. So we know that with blue, the side onto the blue has to go through, again with the red as well. So if we have white, we'd obviously expect there to be a merge between the blue and the red, which is why we end up with purple. So we actually have both our light waves of the red and the blue come through at the same time. We turn to the other side and it turns green. And that's basically the principles of how polarisation of light works. Okay, cheers, thank you.